A savanna or savanna is a grassland ecosystem characterized by the trees being sufficiently widely spaced so that the canopy does not close. The open canopy allows sufficient light to reach the ground to support an unbroken herbaceous layer consisting primarily of grasses. Savannas maintain an open canopy despite a high tree density. It is often believed that savannas feature widely spaced, scattered trees. However, in many savannas, tree densities are higher and trees are more regularly spaced than in forests. The South American savanna types Cerrado sensu stricto and Cerrado dense typically have densities of trees similar to or higher than that found in South American tropical forests, with savanna ranging 800-3300 trees, ha, and adjacent forests with 800-2000 trees, ha. Similarly, Guinean savanna has 129 trees, ha, compared to 103 for riparian forest, while eastern Australian sclerophyll forests have average tree densities of approximately 100 per hectare, comparable to savannas in the same region. Savannas are also characterized by seasonal water availability. With the majority of rainfall confined to one season, they are associated with several types of biomes, and are frequently in a transitional zone between forest and desert or grassland. Savanna covers approximately 20% of the Earth's land area. Etymology. The word originally entered English in 1555 as the Latin Savanna, equivalent in the orthography of the times to Savanna. Peter Martyr reported it as the local name for the plain around Comagri, the court of the Cacique Carlos in present-day Panama. The accounts are inexact, but this is usually placed in present-day Magagandai or at points on the nearby Gunayala coast opposite Ustupa or on Point Mosquitoes. These areas are now either given over to modern cropland or jungle. Distribution. Many grassy landscapes and mixed communities of trees, shrubs, and grasses were described as savanna before the middle of the 19th century, when the concept of a tropical savanna climate became established. The Köppen climate classification system was strongly influenced by effects of temperature and precipitation upon tree growth, and his oversimplified assumptions resulted in a tropical savanna classification concept which resulted in it being considered as a climatic climax formation. The common usage meaning to describe vegetation now conflicts with a simplified yet widespread climatic concept meaning. The divergence has sometimes caused areas such as extensive savannas north and south of the Congo and Amazon rivers to be excluded from mapped savanna categories. Barrens has been used almost interchangeably with savanna in different parts of North America. Sometimes Midwestern savanna were described as grassland with trees. Different authors have defined the lower limits of savanna tree coverage as 5 to 10% and upper limits range as 25 to 80% of an area. Two factors common to all savanna environments are rainfall variations from year to year, and dry season wildfires. In the Americas, e.g., in Belize, Central America, savanna vegetation is similar from Mexico to South America and to the Caribbean. Threats. Changes in fire management. Savannas are subject to regular wildfires and the ecosystem appears to be the result of human use of fire. For example, Native Americans created the pre-Columbian savannas of North America by periodically burning where fire-resistant plants were the dominant species. Pine barrens in scattered locations from New Jersey to coastal New England are remnants of these savannas. Aboriginal burning appears to have been responsible for the widespread occurrence of savanna in tropical Australia and New Guinea, and savannas in India are a result of human fire use. The maqui shrub savannas of the Mediterranean region were likewise created and maintained by anthropogenic fire. These fires are usually confined to the herbaceous layer and do little long-term damage to mature trees. However, these fires either kill or suppress tree seedlings. thus preventing the establishment of a continuous tree canopy which would prevent further grass growth. It has been suggested by many authors that Aboriginal burning created a structurally more open savanna landscape. Aboriginal burning certainly created a habitat mosaic that probably increased biodiversity and changed the structure of woodlands and geographic range of numerous woodland species. It has been suggested by many authors that with the removal or alteration of traditional burning regimes, many savannas are being replaced by forest and shrub thickets with little herbaceous layer. The consumption of herbage by introduced grazers in savanna woodlands has led to a reduction in the amount of fuel available for burning and resulted in fewer and cooler fires. The introduction of exotic pasture legumes has also led to a reduction in the need to burn to produce a flush of green growth because legumes retain high nutrient levels throughout the year, and because fires can have a negative impact on legume populations which causes a reluctance to burn. Grazing and browsing animals. The closed forest types such as broadleaf forests and rainforests are usually not grazed owing to the closed structure, precluding grass growth, and hence offering little opportunity for grazing. In contrast, the open structure of savannas allows the growth of a herbaceous layer and are commonly used for grazing domestic livestock. As a result, much of the world's savannas have undergone change as a result of grazing by sheep, goats and cattle, ranging from changes in pasture composition to woody weed encroachment. The removal of grass by grazing affects the woody plant component of woodland systems in two major ways. Grasses compete with woody plants for water in the topsoil, and removal by grazing reduces this competitive effect, potentially boosting tree growth. In addition to this effect, the removal of fuel reduces both the intensity and the frequency of fires which may control woody plant species. Grazing animals can have a more direct effect on woody plants by the browsing of palatable woody species. There is evidence that unpalatable woody plants have increased under grazing in savannas. Grazing also promotes the spread of weeds in savannas by the removal or reduction of the plants which would normally compete with potential weeds and hinder establishment. In addition to this, cattle and horses are implicated in the spread of the seeds of weed species such as prickly acacia and stylo. Alterations in savanna species composition brought about by grazing can alter ecosystem function, and are exacerbated by overgrazing and poor land management practices. Introduced grazing animals can also affect soil condition through physical compaction and breakup of the soil caused by the hooves of animals, and through the erosion effects caused by the removal of protective plant cover. Such effects are most likely to occur on land subjected to repeated and heavy grazing. The effects of overstocking are often worst on soils of low fertility and in low rainfall areas below 500 mm. As most soil nutrients in these areas tend to be concentrated in the surface, so any movement of soils can lead to severe degradation. Alteration in soil structure and nutrient levels affects the establishment, growth and survival of plant species, and in turn can lead to a change in woodland structure and composition. Tree clearing. Large areas of Australian and South American savannas have been cleared of trees, and this clearing is continuing today. For example, until recently 480,000 hectares of savanna were cleared annually in Australia alone, primarily to improve pasture production. Substantial savanna areas have been cleared of woody vegetation, and much of the area that remains today is vegetation that has been disturbed by either clearing or thinning at some point in the past. Clearing is carried out by the grazing industry in an attempt to increase the quality and quantity of feed available for stock and to improve the management of livestock. The removal of trees from savanna land removes the competition for water from the grasses present, and can lead to a 2- to 4-fold increase in pasture production, as well as improving the quality of the feed available. Since stock carrying capacity is strongly correlated with herbage yield, there can be major financial benefits from the removal of trees. such as assisting with grazing management. Regions of dense tree and shrub cover harbors predators, leading to increased stock losses. For example, while woody plant cover hinders mustering in both sheep and cattle areas. A number of techniques have been employed to clear or kill woody plants in savannas. Early pastoralists used felling and girdling, the removal of a ring of bark and sapwood, as a means of clearing land. In the 1950s, arboricides suitable for stem injection were developed. Water plus heavy machinery was made available, and these were used for either pushing timber, or for pulling using a chain and ball strung between two machines. These two new methods of timber control, along with the introduction and widespread adoption of several new pasture grasses and legumes, promoted a resurgence in tree clearing. The 1980s also saw the release of soil-applied arboricides, notably terbutaron, that could be utilized without cutting and injecting each individual tree. In many ways, artificial clearing, particularly pulling, mimics the effects of fire and, in savannas adapted to regeneration after fire as most Queensland savannas are, there is a similar response to that after fire. Tree clearing in many savanna communities, although causing a dramatic reduction in basal area and canopy cover, often leaves a high percentage of woody plants alive either as seedlings too small to be affected or as plants capable of resprouting from lignotrivers and broken stumps. A population of woody plants equal to half or more of the original number often remains following pulling of eucalypt communities, even if all the trees over 5 meters are uprooted completely. Exotic plant species. A number of exotic plant species have been introduced to the savannas around the world. Amongst the woody plant species are serious environmental weeds such as prickly acacia, rubbervena, mesquite, lantana and prickly pear. A range of herbaceous species have also been introduced to these woodlands, either deliberately or accidentally, including Rhodes grass and other chloris species, bowfell grass, giant rat's tail grass, parthenium and stylos, and other legumes. These introductions have the potential to significantly alter the structure and composition of savannas worldwide, and have already done so in many areas through a number of processes, including altering the fire regime, increasing grazing pressure, competing with native vegetation, and occupying previously vacant ecological niches. Other plant species include white sage, spotted cactus, cottonseed, rosemary. Climate change. There exists the possibility that human-induced climate change in the form of the greenhouse effect may result in an alteration of the structure and function of savannas. Some authors have suggested that savannas and grasslands may become even more susceptible to woody plant encroachment as a result of greenhouse-induced climate change. However, a recent case described a savanna increasing its range at the expense of forest in response to climate variation, and potential exists for similar rapid, dramatic shifts in vegetation distribution as a result of global climate change, particularly at ecotones such as savannas so often represent. Savanna ecoregions. Savanna ecoregions are of several different types. Tropical and subtropical savannas are classified with tropical and subtropical grasslands and shrublands as the tropical and subtropical grasslands, savannas, and shrublands biome. The savannas of Africa, including the Serengeti, famous for its wildlife, are typical of this type. The Brazilian savanna is also included in this category, known for its exotic and varied flora. Temperate savannas are mid-latitude savannas with wetter summers and drier winters. They are classified with temperate savannas and shrublands as the temperate grasslands, savannas, and shrublands biome, that for example cover much of the Great Plains of the United States. Mediterranean savannas are mid-latitude savannas in Mediterranean climate regions, with mild, rainy winters and hot, dry summers. Part of the Mediterranean forests, woodlands, and scrub biome. The oak tree savannas of California, part of the California chaparral and woodlands ecoregion, fall into this category. Flooded savannas are savannas that are flooded seasonally or year-round. They are classified with flooded savannas as the flooded grasslands and savannas biome, which occurs mostly in the tropics and subtropics. Montane savannas are high-altitude savannas, located in a few spots around the world's high mountain regions, part of the montane grasslands and shrublands biome. The lowland savannas of the Angolan scarp savanna and woodlands ecoregion are an example.